Hi everyone, welcome to Competition Valley. My name is Prashant and still we're continuing factorials. We would have another 3-4 videos on factorials before we would have finished it. So in our last videos, what we have seen is we used to have factorials and we could find highest power or trailing zeros. This is what we have done in our last videos, that we were given factorial. We are given, let's say, 20 factorial, and we could find highest power of 2 over here, let's say any number. Similarly, we were given 20 factorial and we can find how many trailing zeros it would have. Okay, it had a fixed pattern on how to find these things. Now let's assume for a moment that we are given, in fact we are not given, or we got to go to reverse. So let's say I'll just make it so that we can correlate. Earlier we had factorials and we could find highest power, and also we can find trailing zeros. Okay, now what are we trying to do? We are trying to go reverse. So let's say we have been provided with highest power and with trailing zeros, and we need to what do we need to find? Factorials. Okay, this is what we are trying to learn now. So as in this case we had a fixed pattern to do thing, we don't have any fixed pattern over here, so it's more of a hit and trial. Of course there's I would say fixed pattern for hit and trial. We can get as close as possible, but just by looking on it we cannot do it what we used to do in previous cases where we had factorials and we just needed to find highest power and trailing zeros. Okay, so we'll try. Let's see how it goes. So let's start with a question. Okay, any random question, we'll take it. So let's say how many values can n take if n factorial is a multiple of 2 to the power 20 but not of 2 to the power 25. Okay, now see over here, what do we need to find and what all we have been given over here. So we have been given the powers. Okay, just focus on the question. Every time you get a question, especially in examination like CAT, if you can interpret the question, see, I've been repeating this so many times, that if you can interpret the questions, you have done 90% of the job. Okay, just don't go by the words. See behind the words, what exactly are they asking? Okay, so see, you have been given the powers over here. Okay, now what do we need to find? We need to find how many values can n take if n is a multiple of 2 to the power 20, or but it's not a multiple 2 to the power 25. Okay, don't complicate over here. Okay, so we'll make it very, very simple. So let's say, okay, we have been given that n is a multiple of 2 to the power 20. Okay, so we'll try to find how many 2 appears. Okay, in if I go like this, in 1 factorial to 10 factorial, how many 2's do we get? Okay, just see. So if I go, so 2 5 2 7, in 2 we would have around 2 5 2 7 8, I believe. Okay, around in 10 factorial, if you want you can calculate this. So 5 2 1, so 2 to the power n. So the highest power of 2 in 10 factorial is 2 to the power 8. So we are just taking it. Okay, this is how we are trying to break it. And again in 11 factorial to 20 factorial, this is the bare minimum we would have. Okay, see, I understand over here it would be more than 8. Okay, but we are just trying to make a pattern over here. Okay, so let's say so this is 2 to the power 16. Okay, so we want to find number wherein the power is 2 to the power 20. Okay, so let's see if it is close to 20. So if I go for 20, so it will be 10, 5, 2, 1. So we have 10, 15 to 17 and 18. 20 is 2 to the power 18. Okay, then 25 it would be this, sorry, 21 it would be the same because we are not adding any. In 21 there is no 2 getting added, so still it would be this. In 22 we can check. In 22 it should be that. So 11, 5, 2 and 1. So 5 to 7, 1, 8. 5 to 7, 1, 8 and it's 19. Again in 23 there would be no it will be the same because there is no addition of 2's. So 23 it will be the same, 2 to the power 19. In 24 it will be more than that because there are multiple 2's that are getting added. So 12, 6, 3, 1. So 3, 10, 22. So you have over here 2 to the power 22. Why? Just because what is 24? 24 is 2 into 2 into 2 into 3. So there we are adding 3 2's extra over here. So therefore it will be skipping 0 concept. So from 19 it will be 22. Okay. So again, so we see that 24 factorial has 2 to the power 20. Now you would say that there is no number that has 2 to the power 20 factorial. That's okay even if you don't get it exact 220, but it should be more than. I'll tell you why. Because even see, when we say 2 to the power 22, what do we mean? We mean that 2 occurs 22 times in 24 factorial. So if it is occurring 22 times, it certainly means that it is occurring 220 times as well. So we can say this is like this, we can write it down, isn't it? So it means that 24 is a factorial of 2 to the power 20 as well as 2 to the power square, making a total of 2 to the power 22. So that's simple. So we shouldn't be focused about getting it exactly the same term. But yes, anything less than that, 2 to the power 19, it would not have 2 occurring 20 times. It certainly may not be a factorial, may not be a multiple rather. So therefore understand, even if you don't get 220, that's okay. Anything above that, if you're getting which is very closest, that should be fine. So it says that, see, don't worry, we'll do many questions related to that so that you understand what we are trying to do. It says, how many values can n take if n is a multiple of 2 to the power 20, but not of 2 to the power 25, okay? So 24 is 2 to the power 20. Again in 25, we are not adding any 2. So in 25, the power will be the same. In 26, we are adding 1. So 23, in 27, 28, it should be 2 into 2 into 7. So it should be the same in 28 if we see 14, 7, 3, 1. So 7, 25. Yeah, it's going to be the same over here. In 28, we have 14 plus 11, 25. So 25 into, and then in 30, we have 15, 7, 3, 1. Okay, but we just need 25 itself. Okay, the question is 25. So 24 over here is 28. Okay, 28 factorial, the highest power is 2 to the power 25. Okay, so what does the question say? That how many values can n take? N is a multiple of 2 to the power 20. N is a multiple of 2 to the power 20. Okay, but not of 2 to the power 25. So all those numbers after 24 factorial would be multiple. All those numbers, if I say over here, okay, so we have 24 factorial, 12, 6, 3, 1. So 22 to the power 22. What was the question? The question 2 to the power 20, I believe. Okay, and if we go back from here to, and the other was 2 to the power 25, I believe. So 25 was 28 factorial. 14, 7, 3, 1 is 2 to the power 25. So see, what is the question? The question is that n is a multiple of 2 to the power 22, but not a multiple of 2 to the power 25. So what are we trying to do? All the numbers including 24 factorial until it goes up to 27 factorial would be a multiple, but we don't want 2 to the power 20. We don't want 28 factorial, because 28 factorial is a multiple of 2 to the power 25 as well. So it will be 24, 25, 26 factorial. The answer would be 4. How many values can n take? N can take 4 values. Okay, we'll do another question. Okay, just to ensure that you guys get it all, we'll do another question. We can write how many values can n take if n factorial is a multiple of 2 to the power 25 but not of 3 to the power 25. Okay, again, how many values can n take? So again, the same process. First we'll try to break down so that we get as close as possible. So how many times does 2 comes? So again, if we try to solve it in 1 factorial to 10 factorial, the number of time 2 would appear would be 8. 11 factorial to 20 factorial, again 8. 21 factorial to 30 factorial, again 8. So we need 2 to the power 25, so it's almost 2 to the power 24. Okay, similarly in 1 factorial to 10 factorial, how many times 10 comes? So it will be 4. 3 3 9 4. Yes. 11 factorial to 20 factorial, how many times? Again 4. So we have 30 factorial, 40 factorial, 50 factorial, 5, 60 factorial. So close to 60 factorial we have 3 to the power 24. Okay, so that's how we can see how we can go about it. So we need 2 to the power 25. So we can start with we see over 30, so we can start with 24. Let's say in 24, what would be the highest power of 2? 12, 6, 3, 1. So it's 22. In 26 it will be 1, 23. In 28, 14, 7, 3, 1, 25. What do we know now? N is a multiple of 2 to the power 25. What it means? N is a multiple of 28 factorial, but n is not a multiple of what? 3 to the power 25. So we need to see what factorial carries 3 to the power 25. So in 60 factorial, if we go about in 60 factorial, so how many we are getting? 26 to 28 we are getting. So less than that. In 58 there is no, in 59 there is no 3, in 58 no, 55, 56, 54 factorial if we check, 18, 6, 2. So we are getting 26. If we go 51 factorial, 17, 5, 23 over here. Okay, so we can be good with 54, because in 51 it's coming 17, 5, 1, 5, 1, 6, 23 is coming. Then in 52 you don't add any 3, in 53 you don't add, in 54 you add couple of them. So you have these over here. 54 you can write as 18, 6 and 2. So 6 to 8 is 26. Okay, there you go, 26. So what do we want? N is a factorial. N is a multiple of 2 to the power 25. What it means? 2 to the power 25 is 28 factorial, but not of 3 to the power 25. Again, 3 to the power 26 means 3 to the power 25 plus 1 extra 3. So what do we don't want? We don't want 54 factorial, because 54 factorial is 3 to the power 25 into 3. So we don't want 1. So 28 factorial till 53 factorial. So how much do we have? 53 minus 28. So we have 25 plus 1 is 26. So how many values can n take? 26. Just look over here. Not that difficult. Okay. We'll do another question. Make sure you note down these questions. Okay. We'll do another question again. again the same, the language remains the same. How many values can n take if n factorial is a multiple of 3 to the power 20 but not of 3 to the power 25. Again, similar approach remains the same. We need to find 3. So first of all, we'll try to find how many times 3 appears in 1 to 10 factorial. Again, we got to go the same way. We need to reach 20. So 3 4 3 4 3 4, it will be 10 12 30 40 50, around 50 factorial we should check for 3 to the power 20. So if we check in 50 factorial, it's not going to help us. So 48 we should check. So in 16 5 1 22, we're getting in for 3 to the power 22. So let's go back step. In 45 factorial, if we check, so we're getting 15 5 1 21, we are getting 21 we are getting over here. Okay, so if we go back to 42 14 14 4 1, we're getting 3 to the power 19. We can't take 3 to the power 19 because this is what we need, so we can take this. So 3 to the power 21 is what? 3 to the power 20 plus extra 3 into extra 3. Okay, so we can consider this as 45 factorial. So how many values can, if n is a multiple of 3 to the power 20, n is a multiple. Now read the question. N is a multiple of 3 to the power 20. 3 to the power 20 represents what? It represents 45 factorial. And it says n is not a multiple of 3 to the power 25. So 3 to the power 25 represents what? 48 is 26. 22. Sorry. Again 51, 54, if we get 18. 18, 6 to 26 we have. So 26 in 51, how much we have? 17 5 1. Okay, so 54 is 3 to the power 26. So we'll take 50. Because 3 to the power 25, 3 to the power 25, what does it represent? 54 factorial. So what do we have as an answer? So n is a multiple of 3 to the power 20. So it will take 45. Now every number after 45, 46, 47, 48, 49, every number up to 53, we would have this thing. It will be a factorial. It would be a multiple of 3 to the power 20. So we keep going till the time we meet 3 to the power 25, because n is not a multiple of 3 to 5. So how much we should have? It should be 54 plus 1, 45. So it would be 8 plus 1 is 9 would be answer. Okay, that's how it is. Just look at the question. Any doubts, let me know. Okay, we'll do one more question just to ensure that you are getting it properly. We'll just write it down. How many values can n take if n factorial is a multiple of let's see what number we can put, 3 to the power 16 but not of 3 to the power 22. Okay, so you can start again. What do we know? We know that in 1 to 10 factorial, how many times does 3 occurs? 4. So we need to say 16. So it will be around 40 factorial, 10 factorial, 10 factorial, 10, 20, 30, 40. You'd have. So let's check for 39. Okay, in 39, if we check, we're getting 13, 4, 1. We're getting 18, 3 to the power 18. If you check in 36, 4, 17, 35, 34, in 33 it would be less, 11, 3, 1, 15. Okay, so 15 we don't need to check, so we can, 36 should be fine. Okay, so n is a multiple of 36. Okay, but not of 22. 22, where are we going to get 22 about here? Okay, so 16, 50. So if we take 54 again, how much was that? 18, 6 to 26 we are getting. So 51 we can take 48. So it is 3 to the power 20. Okay, so up to 47 we can take. So all those number 36, 37, if we keep going like this, so we would have it. So how much we should have it? So 11 plus 1 should be 12, should be the answer. So n can take 12 values. Okay, just check it. Okay, so now I hope this is clear now. Okay, we have done ample questions. You can make any questions onto this, and you can search from internet as well. Don't go to the solution part because you may not find, but just copy the question and try doing it on your own. Try to create aptitude, so problem solving aptitude. Okay, so what we have learned now, what we have learned is we are given some sort of, I would say, highest power we are given, and we are finding factorials. Okay, earlier we were given factorials and we used to find highest power. Now again what we need to do is we will be given trailing zeros, and we need to find factorials. Okay, that's the aim. So let's start. So let's say question says factorial of a number has, you can put anything, let's say 60 trailing zeros. Okay, so we can take what could be the least value of that factorial number. Now very simple. Whenever you get such questions, okay, whenever it says that this is what has this many zeros, 60 trailing zeros, it says, so any number of trailing zeros that you get, you have to simply multiply it by 4. Okay, just first of all, and then we'll come on to the question again. I'll explain you why it says what could be the least value, but just understand first, it has given 60 trailing zeros. So any zero, it could have been 100, 250, 500, any, doesn't matter. We are not bothered about that. And then we'll see how many zeros does this number have. So again, if we find it, so 50, it's 5, 4, 88, I believe. 48, I'm sorry. Then we have 8, no, it could be 9, 3, then 1. So we have 58 trailing zeros over here. How many do we need? We need 60. So in 245, if we check, we are adding only 1 zeros, so it is 49, and then we have 45, so 9 1 10 is 59. So how much we have? 250. In 250 you have 50, and then you have 10, and then you have 2. So how many do you have? 60, 2 trailing zeros. Okay, how many? So in the exact 60 trailing zeros you would not have, but if you have an option over here, if you have an option, it says there's no exact factorial with so many zeros, you can pick that. Otherwise 250. Okay, if it says how factorial of a number has exact 60 trailing zeros in the question, then you can simply say it cannot be determined, or there's no option that would satisfy it. Otherwise you can say that there's 250. So don't worry about the answer here, just understand the concept. What we have done, any number that we have been given, and that from where we need to derive the factorial, we need to multiply it by 4, and then we need to find what could be the easiest, what could be the closest number. And then we see 58 trailing 0, so we just need to go 2 step ahead. 59 over here, and then we are adding extra 0, therefore it's 62. So we can consider this way. I'll give another question, hang on. Factorial of a number has 95 trailing zeros. What could be the least value of that factorial number? Okay, again, what are we supposed to do? The moment we see it's 95, so we are going to multiply it by 4, so 380. Now we need to find how many zeros do we have in 380. So 5 7 38 66 5 3. So how many do we have? 50 318 plus 76 plus 18 is 94. But how many do we need? We need 95, so we'll go a step ahead. So 385, it will be 377 15 3. So we have 95 trailing zeros. Okay, so what is the number? 385 factorial has 95 trailing zeros. Now look at the question. Every such question would ask you what could be the least value of that factorial number. Okay, see, why is it asking for least? Why does not it say that exact number? I'll tell you why. Because when we were reading this, you would have seen that, see, 1 factorial to 4 factorial, how many zeros? 0 trailing zeros. Okay, but if you go to the next step, 5 factorial to 9 factorial, see, it's a series of number, each would have 1 trailing zeros. Even 5 factorial, 1 zeros. 6 factorial, 2 zeros. So 6 factorial, 1 0. 7 factorial, 1 0. 8 factorial, 1 0. 9 factorial, 1 0. So each one of them has just 1 trailing zeros. So therefore it asks for the least. Okay, so the least over here is 5. Similarly, over here is 385. Okay, we'll do another question. Let's say factorial of a number has 112 trailing zeros. What could be the least value of any such factorial? So 112 we have, 112 multiplied by 4, what do we get? Okay, now simply follow the steps. So how much we get? 5 8 89, then we get 17, then we get 3 20 plus 89, 109 we have over here. So that's one trailing zero. So if we go ahead, we go to 450. So we have 90, 18, 3, so 18, 3, 21 and 90. So you have 190 plus 21. You have 111. We may go one step ahead. 455. 5 9 1 18 3. So 18 3 11 plus 18 3 21. So okay, so 455 factorial is the least value to have how many zeros? 112 trailing zeros. So today we have learned the concept. So what we have learned today? We have learned that we have been given highest power, and we have been given trailing zeros. What did we find? We found factorials. Okay, and we have already done this. From factorials we have already derived highest powers and trailing zero, so it makes a complete 360 degree. Okay, so this is all in this class. In next class we will have some other interesting concepts. Till then, go through this video, revise, go through the previous videos as well. Okay. Thank you so much. This is once again Prashant, and we'll meet soon.